Hi everyone. All right, we're back. Unit 9, Day 2 notes, angle and arc relationships. This is my favorite set of notes. It's like a puzzle. I'm going to give you one piece of information and you can find out a whole bunch of other pieces. All right, so recall there's two relationships we already learned from day 1. So the first thing is central angles. It's something you need to look for. Try to identify the center of the circle and look for central angles. So they're going to be line segments that come off of the center point. So remember the relationship that the measure of the angle equals the measure of the arc. So kind of shortcut, the angle equals the arc, 70 degrees, and then the measure of the arc is 70 degrees. You need to look for central angles. All right, we also talked about inscribed angles. So you need to look for inscribed angles. It's where the vertex of the angle is on the circle. It's completely inside. So your brain needs to be able to zoom out and find the arc that the angle intercepts, or take an angle and follow those line segments back to the angle. So the measure of the inscribed angle is half the measure of the arc. So the arc is 2 times the angle, or the angle is the arc divided by 2. That does not look like an arc. Again, I'm trying to use my little shorthand. Let me fix that. Arc divided by 2 is your angle. All right, so now take a look at this next picture. It says find the measure of angle ABC in circle O. So important, right here, circle O. Right there. They are giving you the circle. I am not giving you any measurements, so you have to figure out the measure of that angle. So things you need to realize is there's a line segment that goes through the center of that circle. That's a diameter. When we have a diameter, we get 180 degree arcs. All right, now also if you are at point A and point C and you follow it back, it goes to that angle. So angle ABC, remember to focus in on the middle letter, that's an inscribed angle to arc AC, so it is half its measurement. It is 90 degrees. That is a right angle. This leads to a theorem that says if an angle is inscribed from a semicircle, then it's a right angle. You could either memorize the theorem or just figure it out like we just did. All right, so there's an example of where you need to look for inscribed angles, look for diameters, things like that. All right, let's try this next problem. All right, the measure of angle ABC is 65 degrees. So ABC, focus in on the middle letter, 65. I'm not putting my degree measurement in there because the picture is too small. All right, find the measure of arc AC. So again, your brain needs to take an angle and follow it out to the circle. I call it zooming out. It intercepts arc AC. That's an inscribed angle. So to find the arc, you are going to multiply your inscribed angle by 2, and you're going to get 130 degrees. All right, now it says find the measure of angle ADC. Well, they want this angle back here. If you follow that one out, oh, look at that. It goes to the same arc. So this is an inscribed angle to that arc. You take the arc, divide it by 2, and you get that same 65 degrees. These angles are congruent. It leads to a theorem. If 2 inscribed angles intercept the same arc, then they are congruent. So again, you can memorize the theorem, or you could just play around with your numbers and realize those 2 angles are going to be congruent. Okay, next page is practice problems. So I encourage you to stop the video, do all these problems on your own, and then come back and check your answers. But I'm going to just kind of keep going here. Find the measure of an inscribed angle that intercepts an arc whose degree measures 140 degrees. So inscribed angle, here's my circle. It's completely inside my circle. It intercepts an arc that's 140 degrees. So again, if you follow that arc back to the angle, inscribed angle is half the arc. So it is 70 degrees. All right, triangle DEF is inscribed in a circle. DE, the length from D to E, is equal to the length from E to F. So I'm going to put my markings in there. That tells me this is an isosceles triangle. And we know the measure of arc EF is 100 degrees. Arcs go on the outside, angles are on the inside. All right, now I want you to find the measure of angle D. So find D, zoom it out, go out to the circle. It intercepts that arc of 100 degrees. So it's inscribed. We're going to take 100 divided by 2, and you get 50 degrees. Anytime you find an answer, put it in the picture, because chances are it's going to help you find the next question. It'll help you find the answer. Now we have to find the measure of arc DE, this arc. Well, I know all the way around a circle is 360, but I don't know that arc. That's not helping. So I got to rely on something else. So like I said, this is an isosceles triangle, and if you have two equal sides, you're going to have two equal angles. So it means this other angle is 50, and now if I zoom that out, that goes to arc DE, so it's going to be twice that angle. It's an inscribed angle. 2 times 50 is going to give me 100 degrees. So again, every time you find an answer, put it back in your picture. Find the measure of angle F. So actually, we already have that. So that is our 50 degrees. Okay? All right, if line AB is parallel to line DC, parallel. When you have parallel lines cut by a transversal, there are all kinds of angles that are congruent. The measure of angle B is 36 degrees. All right, I want you to find the measure of angle D. Well, parallel lines cut by a transversal. Remember, I trained you to look for a Z. When you have the parallel lines, you have alternate interior angles are congruent. So that is 36 degrees. Every time you find an answer, you should be able to come up with the reason, with the mathematical explanation of where you got it from. And actually, in the unit test, some questions you're going to have to explain with a reason. All right, find the measure of arc AD. All right, here's arc AD. Now, coming off of point A are 2 line segments. Coming off of point D are 2 line segments. So if you start to follow them back, that arc follows back to here. But you need to ask yourself, is this a central angle, or is it an inscribed angle, or neither? The answer to that is neither. We do not know the center of the circle. So that is not a central angle. There's not a relationship between this angle and that arc. All right, so let's follow back some other lines. So what if we went this way? Oh, there we go. 36 degrees inscribed angle leads out to arc AD. So if you took your inscribed angle, multiplied it by 2, you're going to get the measure of that arc. Notice I'm labeling all my answers in degrees. All right, let's continue. The measure of arc BC. Same thing. You could start to follow segments back. Again, this angle is not a central angle. It's not inscribed. There's not a relationship between its measure and the arc. But if you follow the segments back this way, it leads to that 36 degrees. You see it? Your brain needs to be able to zoom in, zoom out. So arc BC is going to be your inscribed angle times 2. It's also 72 degrees. All right, the measure of angle A. All right, take angle A. Zoom it out. It goes to arc BC. It's going to have the same measurement as that angle. You have 2 inscribed angles to the same arc. Or you could do your 72 divided by 2, and you get your 36 degrees. All right, the measure of angle C, same thing. If you zoom it out, it goes to arc AD. It's going to be that arc divided by 2, 36 degrees. And again, it's angle B zooms out to arc AD. Angle C zooms out to the same arc. So those angles end up being congruent. And same the other way. Actually, all these, they all ended up being 36 degrees. Okay, so that's how you think about these. Next one. Given line AB, right here, is perpendicular to line DE. Perpendicular, you are going to get 90 degrees. There's 4 90-degree angles there. Circle O. This is important. O, I would like you to highlight the center. When you are told what the center is, you need to highlight it. Your brain needs to find that, and you need to notice that there are segments coming off of point O. There are 4 central angles in here. So we may need to use that fact. Arc BC, the measure of arc BC is 60. All right, first thing I want you to find is the measure of arc AB. All right, so here's AB. Now, a little confusing. How do you find that? All we have is 60. We don't really have anything else. We have 90 degrees, but these are not central angles. So they are not related to their arc measures. They're not central angles. So these are not going to be 90 or anything like that. But what you do need to notice is there is a diameter in this picture. There are actually 2 diameters. If you go this way, you should realize all the way around is 180 degrees, but we already have 60 of it, so that leaves 120 left from arc A to B. So from here to here, there's 120 degrees. All right, the measure of angle A. All right, here's A. If you zoom it out to the circle, it hits that 60-degree arc. So it's an inscribed angle. It's going to be 60 degrees divided by 2, which gives you 30. All right, next it wants the measure of angle C. If you take angle C and zoom it out, it hits at B and it hits at A. So it's an inscribed angle to that 120-degree arc. 120 divided by 2 gives you 60 degrees. All right, the measure of angle AOD. It wants this angle here. Now, that's a central angle to arc AD, but we do not know the measure of arc AD. So there's something else you need to notice. You also have to look for triangles in pictures. If this angle up here is 90, that angle is 30. In a triangle, all the angles add up to 180, so it's 180 minus the 90 plus the 30 you already have. There's going to be 60 degrees left right there. All right, find the measure of arc AD. All right, so now that is an arc to a central angle, and so the measure of the arc equals the measure of the angle. People get so used to doing inscribed angles and dividing by 2, they forget central angle equals its arc. All right, the measure of arc CE. Well, I know the whole thing's 180. There's many different ways you could find this. There's an X, there's vertical angle, so that 60 degrees is the same here. And then this angle is a central angle to arc CE, so the arc will have the same measurement. Okay? All right, I think I'm going to stop the video here because I only have a couple minutes left, and I will pick up in part 2. Okay? Bye.